Alright, this is Nathan Hunter,
Dustin Divis,
Steven Novak,
and this is our project for ECEN 390, Electricity and Magnetism, E&M Theory. And our project was a Tesla coil speaker. First start off with our interrupter here, which takes in a MIDI file from our computer and sends out an optical signal through our fiber optic port right there, which you can see. And then you've got these two knobs here and here, which can increase and decrease the power as well as the frequency. And then that goes into our driver board here.
and on our driver board we receive the optical signal through here, and we just have a low 19 volt power that comes into two voltage regulators, which sends out the desired 5 volts to these two ICs and 15 to the gate driver ICs. The two larger 14-pin ICs are just the inverting gates and latch that takes in this signal and inverts one and keeps the other one its original. And then it comes through and goes into the gate driver ICs, which are designed to output high current for short periods of times, which will go in to drive the other side, which Stephen will explain later. Because these two transistors we have here on these large heat sinks can only switch, I guess, when the current is 0, and that's why we need these gate drivers to ensure that we have a high current and then no current and then high again, depending on the frequency of the signal that comes in through the fiber.
Alright, we'll stay over on the board over here for a sec. We could almost divide this board up between a standard Tesla coil on this side and a Tesla coil speaker on this side. This is some pretty standard Tesla coil hardware, capacitors and diodes and resistors and such, and a simple transformer. And if we were to remove this entire side of the board, we could still have a Tesla coil that would arc and make lots of noise and all that sort of stuff for us. And so that's what that is. And so let's go over here now. This is our windings and our toroid and everything. Here we have our primary side of our transformer, and that is 6 winds to the secondary 1300 winds. And we did some research and did a little bit of some estimating work on our own, and we suspect that coming off the toroid, when everything was arcing, there was 250,000 volts, and up to 10 amps on standby on the primary side, and up to 100 amps when everything was happening. And this breakout rod is up here, and that helps us direct it and make sure that everything's going the way we want to. We're not getting any grounds or shorts that we don't want to have happen. Should we talk about what didn't happen?
Yeah.
Do you want to take on the logic side?
So we didn't get the our Tesla coil speaker to output the high power sparks. What we did get is that depending on the signal that came in here, what notes we played on the keyboard on the laptop, this gate driver transformer would buzz at the certain frequencies. However, when we plugged in the high power to drive the coil, every time we played a note, the fuse would blow, and I guess as a result, both of our transistors would go also, and one of our gate driver ICs. And so we believe that it was just that these transistors weren't switching when there was 0 current, so that our timing was off, and maybe the tuning of our coil was off, so that we didn't get the perfect mesh between this logic and the high power.
That is our ECN 390 E&M Theory Tesla coil final project.